And today we'll be talking about and demonstrating some experiments in ancient Egyptian stone technology.
Good afternoon, everybody. As you can see on the screen, we've got two different types of objects to look at today. The first one on the left is, as it says, a finished experimental limestone vessel. The reason why this was made about 20 odd years ago now was that prior to that I have been doing a lot of research into the evidence for making stone vessels in ancient Egypt, starting as they did in the pre-dynastic period. So in order to test those tools, it was obvious that you need to make stone vessels. But if you like, I'm acting as an apprentice ancient Egyptian craft worker. So I have to make that very clear, because although I have served the mechanical engineering apprenticeship a long time ago, nevertheless, I'm not going to say, okay, I know how to do this. No, I'm going to test it out in a dispassionate way, but as an apprentice. And on the right-hand side, you will see that there are numerous carnelian beads which have been placed into this wonderful necklace found in the pyramid of Amenhotep, which is now in the Bodis Museum, Berlin. You will see that there are so many of those carnelian stones, very sort of reddy colour, but extremely hard. Something like Mohs 7 on the geological scale that's used to determine, the geology scale to determine how hard an object is of stone. To give you an idea, talc is very soft at 2, as diamond is 10. But the scale is geometric, it is not arithmetic. That means that the graph goes up like that to diamond right up here, and number 7 is right down there. So the disparity between 7 and 10 is much, much larger than you would imagine. So that's what we're going to do today. I'm going to have a look at the stone vessels, and then I'm going to show you how the drilling was done. Now then, making stone vessels, number one. The evidence for ancient manufacturing techniques and tools. Yes, we need that evidence. And then the experimental procedure for making a test vessel. So first of all, the archaeological evidence, roughly, vessels themselves, all over the world in various museums. So I've had to do a bit of globe-trotting, obviously, just to look at that alone. Tool parts, not many for vase manufacturing. One tool parts is a stone borer, and then there are tool marks themselves on the vessels, e.g. striations, very fine grooving made by what I think, and I hope to show, are crystals of sand. And then there is evidence of boring, which Andre's just been showing us. And by the way, I agree with your interpretation for the purpose that that was used for, and that they were flint and chert crescents, which were used for that purpose, to get limestone powder. Okay. So then, having found out as much archaeological evidence as we can, I then looked at the pictorial evidence in the tombs. And we're looking at hieroglyphs. We've seen one already in the previous lecture. And tomb illustrations. Now then, when you've assembled all that evidence, you then perhaps begin to make formations in your mind of what sort of tools can be used. And because most of the tools have disappeared of this type, for instance the tubular drill, which I'll be showing you, then you've got to reconstruct things. So that means that me, as a craft worker trained in the 20th century, and now it's the 21st century, I have to try, if I can, to put that to one side and try to go back into ancient Egypt. So 1978, I went there for a study trip to have a look at the environment and have a look at the natural resources in Egypt. Plants, trees included in that, stone, sand, copper ore, and so on. Because without these things, you can't possibly do stoneworking. So I came then to the experimental procedure, which was to examine that evidence carefully, and then to manufacture and use the reconstructed tools that I made to make a test stone vessel. And then I had to evaluate that procedure. I had to examine the techniques that I used, the tools and the marks that I had created, and compared them to the archaeological and the pictorial evidence. And then I've got to criticize myself pretty severely. But first of all, let's look at some of the pictorial representations of stone vessel drilling and boring tools. So on the left, you'll see two representations of one of 3rd dynasty date and one of 6th dynasty date. Hieroglyphs from Saqqara. And if you look at the left, one of the left scene, you will see that there is a shaft coming down from some kind of possibly stone or something that it's in, and at the bottom is a forked part of the end of the shaft at the distal end. And across it is a horizontal thing, which is quite intriguing when you first see it. On the other one, in the same photograph, is what looks possibly like stone weights, possibly, or maybe sandbags, fastened to a shaft with a handle that's coming over like that. And then the shaft is offset part way down, again ending in a forked shaft with something across it there. Now, if you look at the next one to the right, which is a 12th dynasty hieroglyph from the funerary temple of Senusret II at Lahoun, this has been drawn from a painted limestone fragment, and it's in the Fitzwilliam Museum. That shows something very, very fundamental. We have two stones at the top of the shaft, which has got a handle bent over. But now you can see that this second shaft with a fork at the bottom, holding what could be a stone of some kind or whatever, it's lashed to it. Now that's very important to remember this. This lashing of one shaft to another is a fundamental step in the way in which this tool is used. Next we go to a New Kingdom representation of a forked shaft engaged with a stone borer, and you'll see that the stone borer now is hemispherical in shape, and again there is a shaft with a fork on lashed to the main shaft upon which the stone is mounted. Now then, on the final one, we look at the 6th, 12th, 18th and 26th dynasty representations of hollowing stone vessels. You will see that these are held in various ways. The tool is being held, generally it is in this position, like so, and then you see the middle representation is shown as the 12th dynasty, and you'll see, if you look, that there is a changeover from stone weights in the Old Kingdom to stone weights. Now it goes to this central weight, which we saw in the previous one, the New Kingdom representation. And then you go further down to the 18th dynasty and then across to the 26th, and then you go back in the 26th dynasty to the two stones. Is this a harking back to the Old Kingdom, which in the 26th dynasty, other things were also done in a similar way? Now then, tools and techniques for shaping and hollowing hard and soft stones. So there are two main vessel shapes, which require different tools and techniques to make each type. Many design variations are known, but essentially, they usually fall into these two categories of cylindrical vessels and bulbous vessels, where the internal dimension is less than the diameter of the mouth. This is critical. Very, very difficult to make now. A cylindrical vessel, straight down, no problem. The bulbous one, a different story, it's going to cost a lot more to make. We continue the same theme here. There are a number of soft and hard stones employed for making stone vessels. experimental cutting of stones with chisels and punches made of stone, copper, bronze, and iron, determined that stone hardness falls into two convenient groups. The soft stones, inverted commas if you like, Mohs 3, up to Mohs 3 on that scale, and below. So we say hard will be above Mohs 3. So examples of soft stone vessels are gypsum and steatite. But examples of hard stone vessels, and I put a picture of a 4th dynasty grand sarcophagus at the Brooklyn Museum in New York. We've got breccia, calcite, calcite. Yes. Egyptian alabaster, Mohs 3 or just slightly above with my test. I would put it about 3.5. Does it need different tools to work that? Yes, it does. So I count it as a hard stone. Diorite, granite, porphyry, and schist. Some examples of very hard stone. So we carry on from that theme. 4 main sets of tools in use for making stone vessels in ancient Egypt, determined by the archaeological evidence and by experiment. First of all, tools for shaping soft stone of hardness Mohs 3 and below. Examples, gypsum and steatite again. Also, secondly, tools for shaping, remember, shaping, we're at the moment, hard stones, of hardness above Mohs 3. And those are the examples again repeated for you. Now, this shaping business is very important. The archaeological evidence, the pictorial evidence shows all stone vessels were shaped before they were ever drilled or bored out. So now we have then to differentiate the tools for drilling, and I emphasize the word drilling, soft and hard stone vessels, and tools for boring soft and hard stone vessels. Now we've got to get that set correctly, and then we'll know exactly how we should use these tools in getting the vase made. And by the way, this vase is limestone for a good reason. It's soft, and I am. So I had to have something that I didn't have to use a massive amount of work. Even so, nearly 24 hours for the little vase that you can see there, one at the beginning of the presentation. So we carry on. Tools for shaping soft stones of hardness Mohs 3 and below. Flint, chisels and punches. You can still use those on soft stones. Copper and bronze chisels and mallets. Of course you can use copper and bronze chisels and mallets. The tests say so. And copper adzes similarly with, after, sandstone smoothers of different types of stone in terms of being coarse and smoother and smoother and smoother still. And very importantly, flint scrapers. Scraping is a very well-known thing today. Scraping, very important thing indeed. And the next one is tools for shaping hard stones of hardness above Mohs 3. Flint, chisels and punches again. Stone hammers and sandstone smoothers. And there you can see some examples there of flint tools which you can use, the copper chisel and the adze. Now then, there are some drilling and boring dissimilarities here which are extremely important to note. First of all, stone borers for stone vessel manufacture were first thought to have been rotated with a bow, like a copper tubular drill. However, experiments with reconstructed tools reveal that this method failed to turn the borer due to inertia and a high level of friction generated by the sand abrasive. And so if you look at the photographs here from left, right, you will see that it was thought by Sir Leonard Woolley that the stone borers that he found, and they've also been found in Egypt as well, that the fork shaft that went into the two cutouts on either side, that shaft was rotated, as you can see, by a bow, with a capstone above for it to rotate within. But all the evidence shows from the experiments that this is not possible. If you look to the right of that, rotating a copper tube, a copper drill with a long bow, the capstone being held by a third worker. This was the experiment we did in 1999 at Aswan, and we drilled a very big hole into granite, and this is the core that came out, and that's the way it came out. That's the correct way. That's the bottom, and that's the top. You'll see that it tapers. Very important to recognise that a tubular drill, because it rotates around the top and precesses, if you're not strong enough to hold it due to the bowing action, then it creates a core which is that shape, and the hole it's in is that shape. So that's very important, because in stone vessels that we have, there is evidence that the core is parallel, not tapered. Therefore, the tubular drill for making vases, vessels, was not rotated with a bow. It was rotated in a different way. And the other one, on the right-hand side, that one, you'll see the thing that I'm talking to you about. There is the core, still in position in the hole, and it was knocked out the chisel. Then, if you look at the drilling, you'll see that the tools are copper, and then later probably bronze tube with a drill, a bow, and a capstone. Sand abrasive, which is the actual cutting medium. The quartz crystals within the sand, pardon me, are the ones that are rotated around by the copper tube. They embed in that copper tube, and then they score the stone, hence the striations. And a reverse twist tool, which you'll see over there on the left of the table to you, fitted with a copper tubular drill. Okay, so why may we use a bow drill for certain parts of the vase? Not for making the vase itself, but for some of the vases having lugs which were drilled out with a tubular drill. The one in the Manchester Museum, made of diorite, it's got two wonderful long tubular lugs, and they were drilled from each side, and they taper, so I know that they were done with a tubular drill driven by a bow. And boring. Now, we have granite, bored with a reverse twist tool fitted with a fork shaft and a figure of 8 shaped stone borer and sand abrasive, conical shaped borers to make the mouth of the vase, and we've got samples of those in the Petrie Museum, and sand to define the mouth with the sand as well. And then tools for boring soft stone, for instance at Es Soan in the Fayoum. Gertrude Catton Thompson found 4th dynasty presents which still had gypsum adhering to the edges that were doing the cutting. Now then, that is just to take you through some basics of making stone vessels, but I also want, while I'm here, to take you through the basics of doing stone bead drilling. Now, these two sets of procedures, that's drilling beads and drilling stone vessels and bring them out, have some similarities to them. One of them you can see is the great big bow that the worker has here. So drilling stone beads, and I'll just do an overview of this, evidence for ancient manufacturing techniques and tools. Now then, before you could ever have the procedure that I'm showing on the screen now, you had to have single bow drilling. A single bead drill for making one hole through one bead. Now, the threading hole was very difficult to create because they were generally around 1 millimetre in diameter, maybe 2. And also, if it was a long convex bicone bead, let me just find one for you here. That's the shape of a long convex bicone bead because you have the convexities at the end and it's fairly long. Now, in order to drill that, you have to drill it from both ends. The reason is if you try to drill it through in one go, you can be certain that the hole would never come out at the exact point you want it to do because you've not got the drill straight going down. So they always used to drill those beads from this way, turn it over, and then drill it again. And very often the holes didn't meet. They would just be like that, offset, and then you would have to persuade them by a bit of jiggery-pokery to just join a bit better so they can get the thread through. Now, during the New Kingdom period, something happened. A change happened to the way in which drilling was done. In this picture, you can see a single craft worker drilling 3 stone beads from the tomb of Rekhmire at Thebes. Now then, I want to point out some things. Norman de Garris-Davies did a brilliant drawing here. What he did was not only do the drawing, he also made comments on what he saw in the original painting on the wall. And what I need to draw your attention to is the long bow. It's about 4 feet long, about 1.2 meters. You'll see there are 3 drills, 3 sticks, and then the string of the bow is going round 3 rods, which Norman de Garris-Davies said were yellow. And because of the period, they will be bronze. Then there's a table with 3 legs for stability. Got one here today. And you'll notice that the sides of this table are very deep. And I say to myself, why is that? We shall see. You'll also see that the gentleman doing the drilling has his foot extended, in fact his left foot, and he's got it on one of the legs of this table here. And he must be therefore holding it down. This is only one of 3 methods that the Egyptians used to make sure that table stayed steady, and we'll come to the others on the demonstrations. Look below at the drawing B, a New Kingdom bead making workshop at Thebes, Upper Egypt. 2 of the craft workers each using 4 drill rods. And this is from the tomb of Sebek-hotep at Thebes, which is now in the British Museum under the 920, that's the number of it. And this shows, even though the ancient Egyptian protocol of showing something flat is to show several layers like that, they're actually showing a workshop at Thebes going hell-bent to making beads at the fastest rate they can possibly do it. So look how many drillers we've got. We've got 2 in the upper register, and we've got 2 in the lower register. Well, then 3 or 4 drills each. This means that the cost of beads is coming down, because one of the most expensive parts of making a necklace are the beads, the stone beads, which have got to have threading holes. So already you can see there is mass production. So on the next slide I'm showing you now, you see that this is for single stone bead drilling tools and techniques. So this little drill, where did it come from? Well, George Andrew Reisner was excavating Kerma, which was an Egyptian colony at that time in the Second Intermediate Period. And he found this little drill. It's a smashing little drill, it really is. It's fit for its purpose. It's made of bronze, as the period would suggest, and it exists now, and I created, as far as I could, an exact replica of it. And I shall be demonstrating that. You can see here that I have to hold a capstone in one hand, use the little bow, a little jeweler's bow now. We're out of the heavy stuff now. We want a nice little jeweler's bow. And you'll see that I'm drilling one of the little beads that's set into a block of some description, which we'll come to in a short while. So, 1 person, 1 drill, 1 bead, 1 cost. So that's where we're up to before the New Kingdom period at Thebes. So we look at this original painting by the artist. A little bit of that somebody at the British Museum decided to write on there the number of it right in the middle of the painting. But never mind, it's done now. You will see from the colouring that the rods are brown, that the handles that the men are holding here, and that there are beads associated, on the right-hand side there with this scene. You'll also see that the tables are three-legged as well as the stools. You'll see that under the tables, on the top register, there is a bowl, a kind of a bowl with a little stand with an implement sticking out of it. What's that for, you say to yourself? And then below in the second register, you see somebody putting the beads into the artifact that they're making. So really, when you look at it, on the right-hand side of the top register, again, you see somebody sliding things up and down on a wooden block, probably, and it's possibly got grooves within it with an abrasive paste in order to smooth off the final bit of work that needed for the beads after they've been drilled, possibly. So there we have it all, except for one operation. We're not actually making the beads there, are we? Not making them into shape, but they are drilling them. So if you take it that in the stone vessels, they were finished, more or less, before they did any drilling or boring, might I suggest that also these beads were roughly shaped at the very least, possibly ground to shape, but not finally polished until the person on the right in the top register put the final polish upon those beads. And so we decided to make the tools and use these reconstructed bead drills. So the 5mm diameter bronze drill rod was cast vertically in sand. I had to know whether a bead drill, which was about so long in length by looking at the picture there, and the diameter, which I have estimated by looking at various other things like the person who's actually using it, to be 0.5 centimetre in diameter, 5mm. And the wooden rods, brown, that Norma de Garistide suggested we would, which I agree with. And then I had to make the bow, of course. I made it out of bamboo, but it is to replicate something that is growing in Egypt, Phragmites communis, which is a common reed. And it is just very similar because it's part of the grass family, and you bend it like that, overbend it, and when you let go, it's into a nice arc, which is similar. But they could have used a thin branch from a tree. It would have had the same effect of putting the necessary tension on the bowstring. But when you look to the right at the right photograph up there, you will see that the drill point isn't sharp, is it? It's rounded. And the reason, again, is just like the tubular drill. If you do that with a bow, you find that it actually rotates like that, the bead drill, and therefore it rounds the point. But that doesn't matter, because I think in those little containers under the tables was an abrasive paste, which was obtained from using powdered sand, which was a byproduct of the drilling and the sawing of stone with tubular drills and flat-edge copper saws with sand abrasive. So what happens when you do this? Well, it's about 120 centimetres in length, the bow, as I said. 2mm diameter string. Well, they've got string in the British Museum of the same diameter, made out of all sorts of things then, halfa grass being the chief one. And each rod then rotates clockwise and then anti-clock. I measured the speed at which they're going at, 0 to 1500, shoom, 0 to 1500 back again. So that's going on all the time. 0 to 1500, tremendous acceleration, and then down again and that. And that's what's going on all the time until they get too tired to do it. Or the boss man says you can have a break. So that's where we're up to at the moment. And what I want to do now is change over positions and begin to do some demonstrations. So I'm not going to do much drilling. The reason is it creates this very fine powder which has micron size associated with it. And that micron size dust gets into the lungs, and many of the ancient craft workers drilling stone vessels, hunched over the vessel when they're doing it, are likely to breathe this dust up because my view is that this was done dry. That the sand, which acts as a fluid, and I'll just demonstrate it does, sand has this wonderful property that it is a fluid, in fact. When the particulate size is absolute right, it's a fluid. And so it doesn't need water to make it flow, nor does it need water to lubricate this at all. We're used to thinking you've got to lubricate something like a drill, because our drills are high-speed drills, and they need water, a substance called mystic, it's oil and water, to cool the drill point. These drills do not get very hot, because copper is a very good conductor of heat. Therefore, the speed that I can do this is going to conduct the heat away. So I have to suggest, quite considerably suggest that only dry sand was used for these operations, not wet sand. Equally, you can just pour the sand out when it's got used up and put some new. So what I'm going to do, I'm going to use this drill first. Now, this is a reconstruction, and you'll recognize it straight away now, from the drawings that we've seen. I've decided to use the single stone on this one because it's easiest to work with. But I did mention the name of this. I've named it the reverse twist drill. The reason is that was carved definitely for the human hand to hold it, not to rotate it. If you do, you will severely taper the core, and you will severely make the taper very pronounced on the hole. This is contrary to the archaeological evidence of parallel cores in stone vessels that have not been finished. So, then also you'll see that the weight is at the top, and this is quite a considerable length, and I've no doubt you've probably imagined immediately that if I have a very deep vessel, I'm going to have something that's going to take that tube all the way down. Now, the interesting thing about the tubular drill is that it is bigger in diameter than the shaft upon which it is mounted. That's obvious, isn't it? Now, if you're looking at ancient Egyptian protocol in creating a drawing of something, this is very hard to show that it's got a tubular drill on. You might be able to show, if you did, but they never do. They only show the vase surrounding this, and you can't tell what's in. Is it a fork shaft that's in there, or is it a tubular drill? So, what does it mean? It means that when you drill so far, and the core, and I've already shown you a core, but this is a very big one, but you're seeing that the core is filling the inside of the tube. And therefore, when it is so long, you can withdraw it and break that core off. Now, it's logical, isn't it, that if this piece of wood is part way into here, and you can only drill as deep as the tube is long up to that piece of wood, then once you've taken that out, now you're allowing the tube to go another depth down to the vase. So that's the secret of it. The same with stone sarcophagi, the same reason. Great big drills, you drill part way down, like so, remove the core by putting a chisel in between the core and the stone, driving that down with a stone hammer, and what happens? That just shears straight off. Now, you can't do that too well with a vase, because you're going to shear the vase side out as well, aren't you? I mean, I can imagine an apprentice doing this, you know, he makes a mistake like I used to do. Bang, you know, and the side comes out and the core's still left in the vase. Can you imagine it, you know, taking it to the foreman, you know, don't beat me. But that's what they had to do, and why they had to use a drill that twisted and reverse twisted. Now, you say to yourself, how did that handle get there? Well, imagine a tree branch, a fork. So, if you cut the fork off and then smooth that out, because the branch you're using tapers naturally, you can now put your hand on it, because it fits the human hand. Because when it's shut, you can see the shape of the human hand fits that. Perfect. And then the other hand will grip there. So now you have the tool. But if you're going to make it now to use it on a stone borer, they would have this, the fork shaft. I brought you a better one. That's a better one. You can see now, what am I showing you again? I'm showing you the tree branch again, aren't I? And the tree branch is going up and it's forking. Now, to make the shaft, of course, for the main shaft, they cut that off. But now they want to put it onto a stone borer. So what do? Now you can see the mechanical form of this now. This now twists it like so. But with a tube, every time that you twist it, it cuts along its whole circumference. So even though you only twist it through this action with your wrist, because they only bend this far, which isn't bad. But if you do that and back again, you see, back and forth, back and forth, back and forth, it's really good for your wrist. And it actually rotates the whole tube and therefore cuts around the whole circumference. This is a different story. This one has to be rotated so far again, but when it gets to, say, a right or left full position, you would change the position of your hands on the shaft. So you would re-grip immediately. There it is. You would then get so far, hold that, and just re-grip and round again. And so that's the way that was probably done. So in order to show you now the bow drill actually being used, find the bow somewhere, wherever it is, here we are. This, remember, would only be used for making the lugs, tubular lugs that are on some of the ancient vases. And I've got a piece of stone here. I hope I can put it so that you can see. Will you be able to see all right if I do it here? Okay? Can everybody see that? Now, if I put a little bit of sand in there, first of all, just give it a little touch. Like so. And then the capstone. Now then, there it is. You can see the capstone. And it will be lubricated with animal fat. I'm not going to use any of that. I'm not going to even bother with it because I'm only going to do it in a short way. So put that in there like so. Put that on. And, oh, could somebody possibly hold this for me, please? Could you just hold it for me? You can imagine this is a large piece of stone normally, but if you just hold it there. Now, I'm not going to do it much because I don't want to produce that horrifying powder, you see. But eventually that would turn into, you can already see the grey part. Can I show it to the camera, please? You can see the grey dust that's coming out of there. This is very dangerous to human beings. I don't think they live more than 30, the drillers of stone vessels, because all of the tomb drawings, and there are quite a few of them, and I've only shown you a cross-section today, but most of them, in fact, every one of them are young, except for one man. And he's got wispy hair, similar to mine, you know. And he's got wispy hair here, and he looks, and he's got one of those paunches, you know, for drinking too much beer, because he used to drink a lot in Egypt. And that's the reason why they would die young, because of that. Now, if you look at that, that's just for those tubular lugs that are going through, where they will put a rope through and suspend it upwards on a rope. So we now go to this one, and we're going to use this work in progress here. Now this one's only part finished. I actually did it for Brighton and Hove Museum, and they've got a little film in there of me doing a vase and also doing the drilling of the beads as well. So if you're down at Brighton and Hove and you're looking in the museum where the vases are and the beads, you will see a little film and you'll see what you've seen here. So what we're going to do is this. I'm going to show it to the camera. You'll see on the screens that there are several holes around the circumference. Also, there's one in the middle. Now, if you go in the Cairo Museum, you will see a hard stone vase, not finished, precisely like this. Several holes round. And that's how they excavated Khufu's sarcophagus in the Great Pyramid. They did rows of holes along the sides and the ends. Then they drilled them all down, took the cores out, and kept doing that till they got to the bottom. And then they weakened the central mass, just the same. So this is where it comes from. So they would be making stone vessels long before they ever did a sarcophagus. The reason why they could do the sarcophagus was because they've been doing these stone vessels. Now I'm going to put it there so everyone can see it again. And this time, I'm going to put a bit of sand in this hole that's already been started. Now maybe this will stay, and it's a perhaps it will and perhaps it won't. And then, yes, I think I'd like you to hold it, please. Thanks very much indeed. Now you see, it's a matter of practice and judgment that whether you get that upright. I mean, you could be all over here and over there and over there and over there. It will be. It's like driving a motor car. You're on the right or the left-hand side driving it, but you've got to allow for the vehicle being off-centre to your line of vision. So there we are. Now you can see that I can do this quite quickly. And away we go. And if you keep doing that, you'll go right through the centre of the earth. Well, you might. So you can see it's just something. They'll be talking about something. Because they probably did it in groups of workers. And they'll probably be talking about the local football results. What do you think of Blackpool? Rubbish. Sorry about Blackpool, by the way. So you can see that's enough of that. You can get the idea straight away. Thanks very much for your help. But again, if I pour that out, oops, there we go. You can see it's turning to this grey powder again, quite quickly. So in other words, I've got to change the sand quite often. But I do suggest that they are storing this, particularly when they're making sarcophagi. My calculations for Khufu sarcophagus, 36 tons of sand, we used up. Half a ton of copper was ground down. It took about a year and a half to drill it out, as well as soil, maybe 2 years altogether. Now you can see that if I keep on doing that and then I do the holes, I'm all right, and then eventually do it. Now, I shall use this one, the one that I finished earlier, 26 years ago. you know, it seems that long ago to me that I think this is ancient Egyptian now. So I'm going to put some sand in. I'm going to fill it up a little bit. I'm not going to drink it, don't worry. And I now get the borer that I need for that. Now, this borer is figure of 8 shaped. The reason why, it's because its long axis, that way, where my fingers are, is shorter, obviously, than the axis where the two cutouts are. So that's a reason for that, because you can see what happens. You try and put the bore into the vase, you see, and it won't go in. Oh, you say, that won't do. So what do you do? Well, you get your flint tools, this, and the same tools that you've used, remember, to shape it. And you've used the copper chisel and the hammer to shape it as well. And you've used the chisel made of flint and done that. So when you've done all that, you realise that you're going to have to do something with this bulbed vessel. If it was straight down, no problem. You could use, if it was soft stone, the flint crescent, like they did at Umm Sawan. But no. So we have to scrape a groove by hand. Everything's by hand. So you would get a flint tool that you could get inside there and make an initial groove. Remember, you've drilled it down and then you've removed the core, so you've got a hollow already. So you've made a groove, and this groove allows you to put the borer in that way. And then, using this, which is now fastened, it's not going to do it for you today because it would take too long to mess about. But you've got to imagine now that that is fastened to the main tool, just as you saw in the drawings. And this now, as you know, engages with that. So imagine that the full tool is built. In fact, I might be able to do it by just holding my hand there. So I would say that no, they don't take the tube off. No, they don't have a separate main tool. They use the main tool and merely lash on. And that's why I emphasized it, that you have to lash on this shaft in order to make this turn now. So you turn the borer. So I'm not going to take that off, it's too hard. I'm going to just show you how that borer just rotates a little bit. And I mentioned that you can rotate it so far, like that, and then turn it and do it again. Turn, do it again, and so on. And what happens is, if you use borer after borer after borer, which are longer and shorter, So you've got to imagine that you use the next borer. Sorry, this is a big one. But there it is. But borers which are subsequently longer till you get to the center of the vessel where it's the widest, and then the same borers that you've been using gradually shorter and shorter, so that eventually you get to the bottom of the vessel. You see the bottom there now. Everybody see that? I can't just, yeah, there it is. And you can see that if you go too far, and this is why it was ridiculous for anyone to mention, I'm afraid, that somebody was drilling something above it and it went down into that object. You can see if it was a stone vessel, we'd now have a, well, we wouldn't have a stone vessel, would we? So you've got to measure this as well. And how do you measure things? Well, you do it like that, don't you? There you go. Oh, yes, I've got this deep. Let's have a look at that. Yes. Ooh, I've only got about 1 centimetre to go. So in other words, I stopped just in time. I'm not watching what I'm doing. I could easily fatally damage the bottom of this because it'd be so weak it would collapse. So you can see now you've got to do it now. I'm going to have to stop doing that because what I want now is if we can move this table, please. And we'll just demonstrate the drilling of the beads. Thanks very much. Let's put my clock over there. Now then, first of all, I mentioned that I would show you the single bead drill. Now, I've got to just put this so because I mentioned that the craftware grips this between their knees, or that's one of them, and the other one was put his foot on there, and the other one, just to get it in for you, is this rope. Now, in one of the tomb scenes, the tomb of Puimre, it's shown a rope with 2 knots like that, and I have to suggest that went over there because there were 2 drillers using the same table. One was bow drilling that way, and the other was bow drilling that way. So it's obvious that they thought, oh, I know, we'll put rope on top, put our foot on each end of the rope, like you do, and that will stop it rocking. So I think that's what that's happened. So they are worried about it doing that. So the single, and here, by the way, is an example of carnelian. And this one is an example of amethyst. And when it's polished amethyst, you can see through it because it's translucent. That means that we can see those holes that are having to meet each other and sometimes miss. Right, so here's this. I'll just hold it like so that you can see it. Those at the back should be able to see it, I hope. There. And you'll see that it's got a little handle at the top there, which is force-fitted. That's the engineering term, force-fitted to the little bronze drill. And that's an exact copy of the one that was found at Kerma by Reisner. And mud block. So if we can just look at the mud block for a moment, you'll see that there are beads, rather they are little pebbles. For block in here, that they press them in. In the top? Or is it a solid piece of wood with holes drilled in it and the beads were forced into the holes? Now, if you ask me what my personal opinion is, what the mud brick does, it's in a wooden frame when it's being made, and then you pull the frame off and you make another brick and you leave the one to dry. Full of mud in top. Put your beads in, and when you drill them halfway through, water it so it all softens, break them out, slap a new piece of mud in and put them in upside down so you can now drill them again. That's my solution to it, although I do put a caveat there and say, well, maybe it was done with wood and then holes put in. But I do put the two solutions forward to you. So again, put the bowstring around the drill. So it's a very easy action, actually. It's the way you hold your mouth, as my father said to me. Just put it on like so. And then get it into the hole. You put on your abrasive powder. And then you can do a single hole like that. There's no worries about it, but you'll see that it's wobbling, can't you? Because I can't just keep it under control. The reason is there's a delay in my central nervous system. Sorry to be scientific, but, well, it is. So when I push forwards with the bow, my central nervous system says, oh, left arm, there's an action going with your right arm in this direction here. So what it does, it corrects it, or tries to do, but it's several hundredths of a second too late. So I can never do it. It drives you nuts, doesn't it? But that's the reason why it is rounded at the bottom. And it doesn't matter because the abrasive, which is now down to the microns, to about 50 microns, all smashed up little pieces of quartz. And they embed in there, and for that split second, they're doing the drilling. Right, now, time to set up, because you'll have to bear with me. I'm going to set it up carefully, because I'm going to talk my way through it. And now, this. The bow, fixed at one end of the string. When you put the drill rods on, which you'll see me do in a minute, you have to loosen this off because you've got 3 rods to go around, maybe 5. Some of the tomb drawings show 4, which you saw. But another one, Neferenpet in the 19th dynasty, shows, it's again at Thebes, because all these 6 tombs are at Thebes, shows 5 drill rods. So I did 5. Not going to do them today, sorry. But I can do 5. 2 are made of steel rods, and these 3 here, these are the original research tools. What you see here is all the original research tools. And these are now about 30 years old. And it took about 3 years to work this out, to be certain what it was doing. That was cast vertically. The meniscus, when you've poured it and it cools, molten bronze, goes round it at the end. How convenient, I said to myself. So what did I do then? Well, we got the handle. And I know you're going to say, some of you, why do they have 3 handles, Egyptians? Why don't they have 1 block of wood, put 3 holes in, and say, that'll do? No, they won't, because they wear at differential rates, these bead drills, and one of the drills, or more, would then be rotating in its bearing hole, in this stick, doing nothing, wouldn't it? So that's the reason why I have 3 sticks, or 5 sticks, or 4 sticks, or 2 sticks in the tomb of Imre. And so how was that hole made? Well, shortcut, heat that up again, red hot, and I burnt it in. There it is. It only goes about a centimetre on. Now, carbon, which it produces, is a good lubricant. So naturally, this will rotate without anything in here, just on the carbon. In fact, this is something the Egyptians learnt much earlier when they were making fire with fire drills. They did the fire drill in the hole, and it went and carbonized on them, didn't it? And as soon as it does, because it's a lubricant, what happens to the production of the ash? It declines rapidly. So what did they do? They drilled lots of holes in a block, because they knew that the next hole would be a fresh one. They just roughened up the drill, and then they were able to make fire again. So they already knew what carbon was. The Egyptians already know a great deal. They know about physics, they know about all sorts, friction, they know about gravity, they know about all sorts. So, I did that with the 3 rods. We've got the table. I'm sitting comfortably, so I'll begin. I'm going to just give that a bit of, it's a good exercise this, by the way, you know, gripping it there. And I've got the bow there, and I've made sure the string is loose. Now, I propose a sliding loop along there to tighten it up. And in the tomb of Rekhmire, the artist actually showed thumb across here, but the string has been drawn, I think, wrongly. But the idea of the thumb is to twist the hand slightly and increase the tension on the string if it slips around the drill rods. So it allows you, of course, to loosen it so that you can do it. So what I'm going to do now, especially for you today, I'm going to do this. I'm going to talk you through it. Now what I've done, I've had to mark these 1, 2 and 3 because I know which is the best way for Dennis Allen to hold these drills at one hand. Now the human hand, brilliant, isn't it? If you've got a long thumb, so I bet you they chose, hey, you'll do for a driller, you've got a long thumb. Oh right, you can hold 5 drill rods. Oh great, we can make some money out of you. So, there it is. So you can do that, no problem, because you've got them, all the holes are there. And so what you've got to do is say to yourself, how am I going to put this together? Because it's no good, is it, having all this complicated stuff, and then saying, excuse me, can you help me put this together? No, they're on piecework. They want to make their money. They haven't got time for you. So you've got to be able to do this for yourself. So how are you going to do it? Well, you start off with the drill rods. So you have to say, how do I put the drill rods together? Well, a great deal of difficulty, obviously. Now, here we go. So the drill's being held that way. You see it's point down like that. And I put the string on. And then the other one goes on top, the string goes on. Then he puts another, can you imagine doing 5? It's bad enough doing 3. Then what you've got is the drill rods all surrounded by the string now. I'm just pulling them through there because I know where they generally work best. So that's what I'm doing now. Okay, so when you've done that, you then say, what should we do next? I know. I had to work this out, by the way. You should have seen it at the beginning. I'm all fingers and thumbs like I am now, actually. And you get the drill rods and put them in prepared holes. Now, how do you prepare the holes? You would use a piece of flint tool. A piece of flint. You would then grind it with that twisting motion again until you got a depression in the hard stone bead. And once that depression was there, and you had it set in the mud block that's set hard, or in the piece of wood, you can now do it. Now, you can see what I can do now. I can put these on now. So choose number 1 to go there. Number 2 is in the middle, like so. And then I just have to get those. Now you can see I've let go of it now. As long as I keep those in the holes, I'm all right. There you go. Okay, so I'll get to here now, in that position. And you'll see that that is still on there. So I'm going to ease that back a little bit, like so. And now I should hopefully be ready to go. So there we go now. Drilling at Thebes, 18th, 19th dynasties, New Kingdom. 3 drills at once. Is the camera focused on that now so they can see them turning? Oh. Did everybody see that? Or to use the words of Fred Bibner, did you like that? Right. Okay, so that really concludes what I have to show you. I know there's not much time to ask questions, but I've tried to answer a lot of things with my talk. So I hope you liked it. Thank you very much for your attention. Okay.
Thank you very much. That was absolutely fabulous and a wonderful ending to this afternoon.